O tira, kia ora koutou katoa, ka nui te mihi atu ki a koutou, kua hono mai ki tēnei kaupapa. Me pēhea taku kōrero i te tuatahi, ko Taranaki tōku maunga, ko Waitara tōku awa, ko te Upoko o te Whenua, Pipitea Waiwhetū me te tatau o te pō, ōku marae, ko Ngāti Maru wharanui me te ateawa Taranaki Whānui ki te Upoko o te ika o pouiwi, ko Holden Hohaia a hau, kia ora, ka nui te mihi kia koutou. All right, so today I thought what I'd do is give you a bit of a show and tell, I guess, on how to acquire LiDAR, 1 meter LiDAR data. Now, there's a lot of 1 meter LiDAR data out there, and it's all, generally I go to the LINS data service to get my my LiDAR, and it comes in quite large sets of data. I think I will show you what they look like. You jump onto the LINS data service. I'm currently in QGIS. This is a free and open source platform, this QGIS platform, and I love it for that reason. But it's also got a coordinates. I'm just going to show you what the LiDAR data looks like when you do finally get it from LINS. I'll just move this. Can you still see what I'm doing, Dwayne?
Yep, going well, Eho.
Okay.
I was just one part for you is at some point, could you show us that colourful image you shared if you have something similar, just so we know what we're aiming at?
Yep, sure. I'm just going to get my keyboard out of the way because it's not working. So here's some examples of LiDAR data. And I'll just go. So when it comes in, it looks like this, but it makes no sense to anyone in that format. And that's not the true LiDAR data itself. It's just a picture of the LiDAR data. But that's what the LINS website kind of looks like. But I'll sort of show you. I'll get out of there again. Sorry, this is all a bit random.
We'll share some links for everyone too.
What's that?
We'll share some links for everyone for some access to software and the data and everything as well.
Yeah. Here's what LiDAR data kind of looks like at 1 meter resolution. It's a really so this is the Kauika, I think it's the Kauika Ranges, inland from Napier there, from Ahuriri. And I like this particular set of the LiDAR because it shows how when you color it up using a color band, which is called Turbo, the Turbo color ramp. See, I'll turn that off and I'll show you how when you get right into, 1 meter LiDAR, Dwayne, correct me if I'm wrong, but sometimes, and I've actually noticed this, you can actually see sometimes the indentations of old past sites and things like that with 1 meter.
Absolutely, you can, particularly on top of the Maunga.
Yeah.
And
it's pretty high res. It's pretty high res. Yeah. I mean, you can see those that, that's probably, you can see where the flow path of the river is and that sort of thing. It's pretty high res. And the other cool thing about LiDAR, I might as well just jump into showing you one of the functionalities of LiDAR is you can do things like this. So you can create a 3D image. Don't know if you're seeing that. Are you seeing that?
Yep, it's looking good.
So now bear with me. I think my graphics card is a little bit on the light side to be able to do this, but I'll try. I tried making a, there you go. That's a big layer there. There's about 8 gig worth of LiDAR data in this.
Don't know about you, bro, but you've got something in the middle of your screen.
Oh, that's my tiles.
Database signature.
Is it gone now?
No, it's just in the middle of the screen still.
Oh.
Does it come up for anybody else? I'm seeing a nice clear 3D fly through.
Nothing for me. I'm all, I can't.
Clear,
You know, it's
clear
perfect
for me
here.
too.
Sorry, it was my own one.
Might be your right.
Get by.
So anyway, that's kind of the end product of what you can do with LiDAR. Or one of I'm sure is many other things you can do with it. That's the beauty of LiDAR is you can get that, you know, that 3D functionality, and QGIS has a really cool function just on the front dashboard of QGIS under view, 3D map views, and create a new 3D map view, and you just step through the process of going through and making it a 3D view. But I think maybe what I'll do, Dwayne, is I'll go back to the beginning and show people how to acquire the data. So
that'll be great, because I think everybody can see where we're aiming for now.
Yeah, cool.
That's great.
So I'll turn this off. So what happens once you get familiar with LiDAR data from LINS, you come to realize there's a couple of things that will help you in your journey, I guess, in acquiring LiDAR data. One thing is the index tiles. So you'll see you can visit yourself the LINS data service. You'll see with all LiDAR data sets, there tends to be also an accompanying index tile file. And the index tile looks a little bit like this. It's normally a shape file. In the case of, here we go. In the case of the Hawke's Bay LiDAR, it looks like this. Now, you can see with the Hawke's Bay LiDAR, it covers quite a big area. But the tiles and this is one of the inherent kind of difficulties of working with LiDAR data, and I'm sure there's a way of automating this process, but I'm just going to show you a manual process for acquiring LiDAR tiles. And the index tile layer is a really handy layer to have, and I'll show you why. So when you get into here, when you get up real close, hang on, I'll just turn on. It has a show labels. It'll take a while. You can see the labels identify each tile, and if you're really, you know, if you're keen to find out about the LiDAR for, I'll just make this transparent so this makes a bit more sense to people. Hang on. Oh, that's, what am I trying to do here, Dwayne? I'm trying to change the opacity. Yeah. So you can see the tiles there. if you wanted to grab the tiles for this valley area here, you know what they're called. You know the numbers. You know the tile numbers because it's in there under. I'm gonna have to make them. I accidentally made them transparent. Yeah, you see what I mean? So you can get, you can go into the downloaded folder that you've got from Lynn's and find and grab those tiles. So so I thought what I'd do now is just show you the process for doing that, eh? So you add a few tiles from a larger data set from Lynn's. So I'll turn that off. By the way, if people have got questions as we're going along, I'm more than happy to answer those questions on the way through. That's absolutely fine. So here's the Hawke's Bay LiDAR folder that I downloaded. I downloaded a big chunk of the LiDAR tiles. Now you'll see here there's a mix of file types. You're interested in the TIFFs. Okay, so what you have to do if you're gonna start grabbing LiDAR tiles from your bigger folder is you need to sort your files by kind. So it's the TIFFs you're interested in. And these are you can see here, these are TIFFs. Now, let's say you've identified using the index tiles, which ones you want. And I've got a few here. And it's a simple matter of basically going like this. You just grab them. Oh, sorry. I'm still trying to figure out how to use a Mac, eh? I'm sure there's a button that allows you to select all of these, but who knows? So those are all the TIFFs I'm interested in. And see, you just drag and drop your TIFFs onto your map canvas. And now what you'll notice here is, okay. So the next thing you want to do to be able to make this data usable is you need to merge those tiles because they come in as tiny little tiles like that, right? I mean, so the next step is to merge the tiles. And I'll do that now. So to merge the tiles, you go to raster, miscellaneous, merge, select them all, turn off the ones that you don't want to merge. And
something just there worth mentioning, Ahua. Just see how it says 2193.
Yep.
That is the New Zealand Transverse Mercator Map Grid, and it's the best one for using with LiDAR because it's metric square meters. If you use other, so it's worth just writing that number down. If I know 2193.
I'll do that again.
Square and works.
Yeah.
So that's when you go to the Lynn's data service and it says, what format do you want? Well, you want TIFFs, but also 2193 is New Zealand Transverse Mercator Map Grid, which is is metric, it's square.
Yeah. Yep, that's right. So this is what you're talking about, eh, Dwayne?
Yeah, right. So your QGIS is automatically picking up that metadata from each file.
It's automatically picking up that data about the coordinate reference system. But I'll show you something. Yeah, so while I remember, one thing it pays to do when you're processing LiDAR data in the way I'm doing it is you need to, where possible, load your tiles in squares like this. Now, the reason I say this is because it just makes them easier to stitch together with other squares as you go forward, because this is just a very small area that I'm doing right now, and you will no doubt want to do bigger and bigger areas as you get into it. Remember to load them as squares initially, or rectangles or whatever, just so that they're easier to process. Do you know what I'm trying to say, Dwayne? You've probably got a better way of explaining that.
Absolutely, Hohaia. The other thing, of course, is the more data you add, the slower and longer your computer will be working for. So if it's your first time trying LiDAR, just start with a small sample area like this.
A little square, yeah. So what you've got here, so you've selected them all under your merge command. You go OK. 15 inputs selected. You save it to a temporary file. Oh no, you save it to a file. I'll put this on my desktop and I'm going to call it merged. And you go save, and then you hit run. Now, notice it's done something good to the image, right? It's obviously stitched together or merged those 15 tiles, but it's come up with a bit of a problem in here, and I'll tell you how you avert that problem. Hopefully, I think if you're on a Windows device, it'll pick it up and it'll be okay, but with my Mac, I don't know, the settings are different and I have to do something, and I'll show you how you fix it in a minute. So basically, you've got your merged LiDAR here. I'm just going to get rid of these. Bear with me, because you've gotten what you need out of them.
Holden, do you think that is a new image in the merge you've created, or is it a kind of like a virtual image?
It's a stitch together of, it's a new image.
New image. Okay.
Using that, well, I sort of look at it as a new image, I guess. Option and command, is it? Yeah. How do I select these all in one hit?
Yeah.
I'm on a Mac and I'm...
It'll be one of those. Or shift.
Shift. Yeah, shift. Click on the first one, hold down shift, and click on the last one, I think.
Oh, thank you. I must remember that. Okay, so I'm just going to get rid of the error message for a moment and assume that that wasn't there for a sec. So the next thing you want to do, so it's in a format, I think it's single band gray, which is kind of like not a very useful format, but it's easy enough to change to hill shade. And the way you change it is you go to properties, you right click on the layer, you go to properties, and instead of render type single band gray, you go hill shade. And there you got your LiDAR, high res LiDAR. Now, one thing that I like to do with LiDAR is, I mean, you can put it underneath aerial imagery and it gives it that, you know, that hill shade effect. The other thing I like to do is duplicate it, put the duplicated layer on top, turn it on, and then apply a symbology from the render type drop-down option of single band pseudo color, and then give it this, what's called, I think it's turbo color ramp. It's the turbo color ramp, and I give it about 50% transparency. And then that sort of gives it a bit more, I don't know, I just like looking at it.
What are those colours showing you there, Holden?
Yep, so they're showing from, I think you'll find this is in meters. This is, the blue area is 968 meters above sea level, and the red area is 1,300 meters above sea level. That sounds about right, eh?
It does, yeah, it's pretty high up there.
It's pretty high up. Now, if you wanted to, actually, now that you raise it, if you wanted to change it, so rather than it being a continuous legend, which again is not very useful. I mean, it's kind of useful. It gives you the lowest and highest altitude. The other thing you can do is you can change the legend settings. And when I say change the legend settings, you can, instead of using a continuous legend, you untick that and you go OK. And then you go equal interval and give yourself about 10 classes. And then you can just go like that, and you've got classes instead of a continuous legend. And you can adjust, you can make each thing by 10, 1,310 meters, whatever you can adjust.
Round it off.
I'm not explaining this very well, eh?
I mean, like to put it to whole numbers.
Yeah, you can go like this.
900, 1,000, 1,050, 1,100, something like that.
And so on. And the QGIS software will make the adjustments to the color band in your visual in your map canvas, as well as on your legend. Make sense?
I think that would be really awesome for any, if you're looking at coastal areas as well, if you had a small area that you're looking there and you wanted to, you could even go by 1 meter by 1 meter in height near the coast if you wanted to see what might be affected by sea level rise, for example.
Well, I'll show you in a minute with this Kauika LiDAR data set that I created that goes down from the Kauika ranges where we were right down to the coast. So that'll be a good one to look at. But obviously when you did your final map, you'd put the low altitude at the bottom of your legend and your higher altitude at the top. And you can do that when you're in print layout, if you know what I mean. So anyway, so the next thing you want to do is you want to, with this one, what I've discovered is that you need to reproject this one if you're going to turn it into a 3D image. And I can't explain why, I just know that you have to. Maybe you can explain why, Dwayne. Is
it that I think because your 3D viewer is not using the 2193 square map grid, it's probably using a 3D globe for the whole planet. And gotcha. Which one are you going to translate it to, Holden?
So what I'm going to do, because I know this works, is I'm going to reproject this layer. And I know, I can't explain some of the things I do. See how that says merged? Oh, actually, I'm going to do the merged. Do the merged one. I'm going to reproject it. See that input layer looks as if there's no coordinate reference system associated with it, which kind of, I don't know, Dwayne. Anyway, all I know is if you do this and go source CRS EPSG 2193, you target CRS EPSG 2193. You might not need to do this, I guess is my point. Your settings might be all good to go, but in my case, they weren't. Save to reprojected. I'm going to call it reprojected.
So it should go pretty quick because I think all it's doing is assigning
Yeah.
properly that 2193. Yeah, so it's done it really fast.
It's done it fast. And I'll get rid of this one. And I'll get rid of this one. And I'll show you how to turn it into a 3D image.
So I think what's happened there, Holden, is the software is kind of recognized, but not quite recognized that it was in 2193 format. And now you've really told it, absolutely, it's in 2193.
The funny thing is my PC laptop, it just does it automatically. The Mac, QGIS behaves slightly differently on a Mac. That's all I'll say. And you have to kind of get your head around some of the kind of little funny things it does. And this is one of them. But yeah, as I say, you go back into your render type and apply the hill shade. I'll just leave it as straight hill shade, eh?
Yep.
And then we go 3D view, 3D map view. I'll create a new view. And a little box window pops up for your 3D viewer. Oops, didn't mean to do that.
It's all picked by, looks good.
QGIS has this funny thing where it docks your windows sometimes when you least want it to. Okay, I'll have to pull that down a little bit. So to turn it into a 3D image, first thing you might want to do is get it into a position where it's going to accentuate the 3D nature of it. And you do that by just holding down your scroll wheel and dragging your mouse. You'll figure it out once you're in. Get it up a little bit further. That'll do. And then you go to the spanner, go to configure. Instead of flat terrain, the terrain type you want is digital elevation model, because LiDAR is a digital elevation model. Or this, yeah. That's right, eh, Dwayne? Is that right?
That's right, mate. Yep.
Yeah. And then you go, what did we call it? Reproject. Now, I find tile resolution, if you bump it up to about 100 and you make the map units under skirt height about 70, you get, it's nice and smooth. There are no gaps in the stitching. And you just go, okay. There you go. There's your 3D image.
It's pretty sweet. So that's on your local computer and you can control any aspect of it, which is the big difference, I think, for when you're looking at other tools.
Yeah. What do you mean?
Or like you can control all the aspects of it, like the color ramps,
Yes.
If you have a look at any of the top of those maunga, you might even spot the odd significant site, but you can control all of the colors and how it's viewed. And
absolutely. Yeah, I mean, you see what I mean? And you can do flyovers. So the flyovers are pretty easy to do. You just, so what you do is, the first thing you do is you get in and you get rid of the 5-second interval. You create your own 5-second interval. Whoops. I like to go in about I'm going to get rid of that one. Create my own 5-second interval. Of course, this would look better if you had it opaque and the hillshade layer was underneath it. Same data set. Do you know what I mean?
Right.
I'll zoom in a bit there. And then you just build your flyover like that.
It's kind of a keyframe must be kind of like a bookmark, is it? You go
The keyframe was like a bookmark, yeah. So that was a 5-second keyframe. So that's gotten me sort of halfway over the ranges. I'll go for another 5 seconds. It's a little bit, it's not always as responsive as you'd want it to be. There we go. I'm just dragging my mouse. So this will be 10 seconds worth of animation.
The first one onto the second one.
Yeah. You know, and you just play around with that. Yeah, so that's just that little button there. And then what I tend to do is I delete the 5-second keyframe that comes stock standard, and I create my own 5-second keyframe, and then I use 5-second intervals to create a bit of a flyover. And that's basically that's how you do it. Yeah.
It's pretty awesome.
So I'll just jump out of here.
It hasn't crashed yet either.
No, it hasn't crashed yet. And the thing, you will need a good graphics card if you're doing big 3D animations like this one that I'll try showing you now. If I can just get the edge of my oh yeah, it was on there. Yeah, so that's a very large data set. See, the graphics card's not kind of coping very well. I think that's that little flickery effect you get. I think that's the
Yeah. Yeah, it's probably what, 100 gigs, something like maybe 50 gigs worth, something like that.
Oh, there you go, it crashed. Yeah, I think it's worked out at about 15 gig, that layer. So if you get into that sort of thing, probably best to invest in a gaming computer that's got like 32 gig RAM and processing capacity and a good graphics card. But yeah, that's probably the end of my kōrero about LiDAR.
Awesome. And how did you figure this out?
To be honest with you, Dwayne, I can't remember. I remember just fiddling around with the files and seeing that the TIFF. I might have Googled how do you download LiDAR data, and then I might have gotten clued on that way, and then I just figured out that you can stitch it together using that process that I just showed you. There is a much more advanced way of getting the whole data set down in one go, and writing some code to do the command to do it all automatically, but I haven't figured out how to do that.
That's what you need though, eh?
I just played around and it does what you need. Takes a long time if you want to do large areas, but it's well worth it because the LiDAR, particularly the 1 meter LiDAR, is so high res. You can really get up and look at the whenua, and the 3D functionality is just kind of had me at the 3D animation, had me at hello, really, when I first started playing with it. Yeah.
So, Whānau, if you have any partai, feel free to just go unmute and go for it. I'm going to keep quizzing Holden if he doesn't mind. So what what types of things have you used QGIS for, Holden?
Oh,
And-
well, I'll show you a couple of things. So I've been very fortunate in that my day job, which is at Taranaki Whānui, has allowed me to reach out to hapua niwi organisations and to offer this QGIS kind of introductory awareness, kind of introductory training in QGIS as a software platform. So I've run over the last 3 or 4 months, probably 9 or 10 sessions with different iwi groups. I don't know, can you still see this?
Yep.
Yeah, and we sort of focus on the tribal area of interest. No surprises. I just recently had a session, really enjoyable session with Ngāti Rangi up in Ohakune there, and we focused on their, this area of interest, which, granted it is an area of interest that you put in as part of your treaty settlement process. It's not your true rohe as known by, from a tikanga and te ao Māori perspective, but it's an area that you can focus on for your map, This is a land cover map, so I tend to do this for with the iwi that I'm engaging with, and we sort of go through the process of how you clip the data into that shape, how you style your layers so that you can see through, for example, the dock layer. You can see through it and see underneath to the indigenous forest category of the legend there. How you make your overview map down here. We go through all this. I really believe in QGIS as a platform for our whānau hapua niwi because it's free. I'm sure ArcGIS is good. I've never used it, but I don't really want to pay for a license. You know what I mean?
Yep. Yeah, when I do guest lectures at Victoria when they did GIS, I always had this little ditty that I said, especially just to annoy the lecturer, but they would ask, oh, should we learn QGIS or should we learn ArcGIS? And I go, well, QGIS if you want to learn, ArcGIS if you want to earn, but someone else is going to pay for it for you. But
yeah,
it's great software for learning and even creating your own maps, eh?
Oh, look, I mean, and your ability to style, the styling functionality in QGIS is just amazing. Some of the stuff you can do. I mean, yeah. I just like the idea that it's free and open source, and what I've found is that quite often our hapua niwi organisations will have an ArcGIS license, but no one really knows how to use it. Which I would say, well, you may as well make the transition to QGIS, and then everyone can learn it, and it costs you nothing. Whereas your kind of dormant ArcGIS license is probably costing you a couple of grand a year.
Yeah, especially if it's a commercial one. I think it's cheaper for non-profit, but
yeah,
it's hard to sustain that kind of funding if you're not using it.
Yeah,
I think the same thing with QGIS. So you've got to put in the time.
You've got to put in the time, yeah. And I'll be honest, I'm a bit obsessed with it. I don't think my wife's as enamored with QGIS as I am, put it that way. But I just love it. And I mean, just learning new things. I mean, how you do these grid borders on your maps, little details like that. Another thing I'm learning about is conditional formatting, so you can color up your attribute table, and just I don't know what it is about QGIS and about mapping, but I love it, hey. And I think it's the color. The color has something to do with it.
There's lots of plugins, isn't there, for different
yes.
things?
Yeah, there's heaps of plugins, and I mean, all sorts of new functionality that opens up with plugins. Travel time is a good one. If you get into QGIS, travel time is a good one. You can show, the route that you need to take to get from A to B in your map with travel time. Walking radiuses, driving radiuses, 5 minutes, what is within a 5-minute radius, driving radius of point A? What is it within a 5-minute walking radius of point A? And it shows you the radius on the map, that sort of stuff. Yeah, travel time's cool.
Can you use it for things like distance to from a marae or from health services, things like this?
Absolutely. Yeah. In fact, you can do that within QGIS itself, eh? I haven't done a huge amount of that sort of stuff because I've tended to focus on environmental data like this land cover layer that I'm showing now. But yeah, you definitely can show that, distance to different services and stuff like that.
And you could also, for environmental data, if you were doing sites that you're monitoring, you could create them as points and have attributes for each one, update it all.
Absolutely. Yep.
Yeah.
So what we did with Ngāti Rangi, I'm sure it's okay to share this. So they have quite an extensive monitoring and tile monitoring space. So they've got a tile team. They all have those handheld GPS units. So the data for their trap lines and that sort of stuff, they can basically, and I showed them, real time in the workshop, how you basically can load it onto your own QGIS platform, have your trap lines come straight up onto your map canvas. And then if you export those GPX files, because on a handheld GPS, the layer will come in as a GPX, but you can't edit a GPX layer. You have to transfer it or export it into a geo package. Then once you've exported it into a geo package, you can add new attributes, add new columns, have more detail around what's, what the state of that data point at that monitoring site, whether it's water or different species or different things that you're monitoring out on the whenua. The functionality is all there for you in QGIS. Yeah.
I think even, little workflows like that, it's not unique to a hapu application. If you just type in YouTube, for example, GPS QGIS, it'll give you a heap of different videos of how to do it for different ways, different purposes, different methods.
Yeah.
And it's always the help, but I'm always too impatient to read the help.
Yeah.
Just want to check if anyone has put a note in the chat. If anybody has any pātai, feel free to unmute and go for it. We go a couple minutes, but if there's no further pātai, we can look to finish up.
I'll stop
I've
sharing.
got a question.
Hi, go for it.
Yeah. With your 3D LiDAR image, how does it react when you drape the other 2D layers over it? Do you have you come across any problems with certain types or data formats?
Yeah, good question. I've never draped 2D data on top of it, but actually that's not true. I've inadvertently left 2D data on top of the 3D imagery, and it just sits there. It sits there fine. So, for example, I can't call it up right now, but point data. So the point data was, layered all over the 3D image, and the flyover just flew over the 3D image, and you could see the point data as you flew over. So I guess in answer to your question, I didn't so much drape it over the 3D image. It was already on my 3D image when I moved into the 3D viewer on QGIS.
Sure.
Does that answer your question?
Yeah,
I guess
other types like imagery, can you, like aerial photos, can you still drape it over it, or
yes,
polygons?
absolutely.
Yep, good. Okay.
Yeah, very much so. And look, I've not got into the habit of doing it, but I know it's doable because inadvertently I left a layer on of point data, It just sits there like any other data. Yeah.
As long as it sits on top and it's representative, in the right place.
Yeah.
Yeah.
You just sit it on top in the normal way, and it just behaves in the normal way in your layers panel, As long as you've stacked it on top, it'll sit on top.
Cool. Thanks.
Awesome. Any further pātai, whānau?
Te ahu nei kua hoha rātou kia tāua e hoa.
Okay, well, hey, I just want to say big mihi to you, Holden, for coming along today and showing us QGIS. It's great seeing how you've progressed over the last couple of years, and it's awesome to see how you're using it and accessing data, using the plugins, getting the data from coordinates, making it your own, and sharing that knowledge as well.